I was just joking about this because it's true. But we are going to go straight into the lab as I promised in the last section, where you're going to do this auto drop from the command line inside of the class VM using your Kali system. Now, we gave you a whole bunch of different steps on how to do this, and I know that some of you actually did do it, but we're going to give it about 20 minutes. So we're going to set the timer for 20 minutes. And then I'm going to come back and I'm going to walk through this thing step by step by step and kind of how I troubleshoot and build things like this. Because I know for people that are relatively new to scripting or any type of coding, this is really scary, right? That it looks absolutely horrific. And for people that have been doing coding for a number of years, they may be able to get it, but I want to be able to walk through what is the thought process of building something like this and what is the thought process of understanding something like this. So let's go ahead and let's set the clock timer for 20 minutes. Once again, the reason why this lab is important and the reason why we do this particular lab is I want people to understand that you can set up cyber deception on the cheap is one thing, of course, but you can actually do it for free and you actually don't need any tools to do these types of things at all. So I'm going to have one prompt here, and then I'm actually going to open up a completely separate Kali prompt, and I'm going to change the appearance of that one as well. And I'll show you why I'm doing two, because what we're going to be doing is taking parts from one and kind of editing the other when we're going back and forth. So we're going to be copying and pasting, because that's all this class is about. It's about copying and pasting. Actually, no, that's not true. That's not true. It's not true at all. It's not all about copying and pasting. It's also, getting into where the different labs are and how the stuff actually works. So let me go to intro class files. Let me go navigation. Let me get caught up with you. Where is it? Honeypot. I guess. Okay. What to do? There we go. Hold on. I got to mess with some stuff here. So the opt ls and go. All right. So we have this honeypot that we're trying to set up in this class. And I thought I had, do I not? Am I missing it? I know that we have the slides, right? We can kind of go through it as well. All right, so let's go ahead and pull this out like here. There we go. And escape, pull that down. All right, so did anybody like get this to work? Anybody want to put their stuff into Discord and how they got it to work? Because I do have a solution on this one. Anyone on that? So we'll start by kind of building out. If you guys have your solutions, go ahead and paste that in. So we're going to start with just a basic netcat listener, right? So I can do netcat listen on a port, and we can, with this version of netcat, we don't have to do it. We can actually just specify a port, and we can do 2222. Oh, I need that to be a V. PV, and then we go 2222, like so. And, let's just do it this way. There we go. All right, so now we've got a netcat listener on port 2222, right? The next thing that I can actually do on that, hold on. The next thing I can do is I can connect to it. So I can go netcat to 127. I can go netcat to 127.0.0.1 on port 2222, and I hit enter, and now I've made that connection, right? So if we're kind of taking this apart, I've got that connection is made and I can send data back and forth, but it's not giving me a lot of information about what is being sent back and forth. And I've got to move my stuff here real quick. Let me pull that down here so I can type it in. Right, there we go. And I can send that data, but I'm not getting a lot of info. So let's kind of change this up so I can start getting more information about what is going on about those connections. So now what I'm going to do is I'm going to do netcat, and I'm going to listen on a port. We're going to go netcat We're going to go listen on a port. I'm not going to resolve any names. Let's go exactly as it is. Let's go not resolve any names, be verbose. Let's listen on a port, and I'm going to go 10, 25, like that. So now, if you can see, Netcat is giving us a little bit more information about what's actually going on. It says I'm listening on this specific port, on that specific range, which is literally everything. Now, if I make a reconnection on it to 1025, 1025, at that particular point, if we go back, we now have a really cool string that says connection from, I've got an IP address, I've got a port number, and I have the word received. So what I want to try to do is I want to grab any line that has received. So if we look forward in our actual script, what we're doing, you can see connection from 127.0.0.1. We've got port 403364 or 3336, and we've got received. Awesome. Great. I want just that line, because what I'm going to do is I want to capture just this IP address, and I want to put it into IP tables rule that allows me to create that as a variable. So I'm going to keep building this up. I'm going to take standard error, I'm going to put it into duplicated standard input, and then I'm going to take standard input, and then I'm going to dump that into dev null. Now, the reason why I'm doing all of this is a little bit of housekeeping. And basically, I want to take standard error. Standard error is anything that Netcat produces that's a message to you, the user. It separates standard output from standard error because standard error is messages to you, the user, and standard output is the data it's receiving and transmitting. You want to keep those two streams separate, right? So consider it to be like a log of a web server and the actual data of the web server as well. All right, so we've got that. I can hit that up. Now it still displays the data, and I want to explain why it still displays the data here in just a couple of seconds. When we display the data, we can still see the connection received and we still see listening. The reason for this is it's just right now to our screen, it's displaying to us standard output and standard error. You're going to see here in a second how we're going to be able to just pull out that string of received whenever we put on our grep statement. I'll show you how that cleans up in a little bit. And we also want to use that shell redirect to dev null, because that shell redirect to dev null allows us to clean it up every time it's used. So we're not going to have a bunch of data that's there and just mucking up the works. So I'm going to put in a grep statement for received. I before E, except after C. Did I type that right? R-E-C, R-E-C-E-I-V-E-D. There we go. Now I've got that grep statement. And now let's see if it's any different, right? Let's see if that works any different. Now I only get the line of received. Awesome. Now I only get the line that has that received. So when we're going through and we're doing this and we're kind of building it up, you're going to be able to see, and by the way, whenever my solution is done, I'm going to post the whole solution in the chat for you guys so you guys can type it out. Sound good? All right, so we're building this stuff up step by step by step so you know what's going on. So I want to grab that string of received. All right, awesome. So the next thing that we're going to do is we're going to send this through awk, which there's a number of ways we could have done it. We could have done it through, sed, actually, and we could have done it through awk, we could have done it through cut, but we're going to identify a series of delimiters here where we have our brackets, oops, wrong brackets, and then we are going to pipe that, and we're going to pull out, we're going to invoke print, actually, so we're going to do that, pull out squigglies, we're going to print out the third value, semicolon, let me pull this over just a hair. There we go. We got our semicolon, put in the squiggly brackets, and then I have a single tick, and then I don't need the back tick yet. All right, awesome. So now what we're doing is we're identifying a series of delimiters. Did I miss a greater than? I don't think I did. Maybe I did. I think I've got them. All right, so we'll go through it. So let's see if this actually prints the IP address for the connection. So let's go ahead and take that out. There we go. And kill it. And it didn't print the IP address. Uh-oh. That's not good. I don't know what I just messed up on this. Anybody see my mistake? You read the studies. So I might have had a broken lab here. I might have to come back and do this, editors. During the next lab, I may have to fix this lab and figure out what's going on. Should be after the 2. I do have a greater than after the 2, don't I? Hmm. Yeah, your colleague doesn't like it. It should be working. All right. Um, I don't know what I'm missing on this and what has happened as far as a change on my collie instance. Yeah, if the instructions are wrong, no, I should be able to do that. Control L, do that, do that. Now I've got it running and I should be able to make the connection. It should just print out the IP address. Unless Kali did some kind of update and now all of a sudden it's not working. I don't see anything. Let me try canceling it on this side and see if it prints it after I cancel it on this side. Oh, there we go. Yeah, okay, it's working. Losing my mind, losing my mind. All right. So in this particular situation, what's going on? I'm like, that should work. It doesn't actually print out the IP address until the connection is done. So if I make this connection, it's not going to print the IP address right away because it hasn't flushed out standard output. But as soon as I kill that connection, then it prints just the IP address. Bam. There we go. We have 127.0.0.1. All right. So if we're walking through this step by step, what we do next is we're going to take that and we can assign it to a variable. Let me show you how we do that. We do IP equals, we put in a backtick there, and then we put a backtick at the end. So what's going to happen is we're creating a variable called IP. And then the IP variable is going to be fed whatever the output of that long string is, where we're just pulling out the IP address on this as well. I like that. I learned so much when the instructions are wrong and the instructor has to go off-roading. So yeah, it's just, I usually just do the script and run it. I don't break it up piece by piece by piece. And today I was like, hey, I'll just do it piece by piece. What the hell? So now let me show you how this looks different. So now I started up the script. Now I hit up arrow, right? I make the connection. I kill the connection. Now watch over here. It didn't print the IP address. It didn't print the IP address. No, it's a good approach, Andy, no matter what. It did not print the IP address. Instead, it actually printed the IP address into a variable called IP. So I can do echo and I can do $IP, and now, bam, we have the IP address is in the variable IP that is sitting in our system. That's pretty cool. So what we can do is we can take this heart of this netcat command, and then we are going to build a script around it. So I'm going to go ahead and I'm going to do vim, and I'll just call it, let's just call it honeyport.sh, right? We're just going to call it a shell script. It's going to create the new file. There we go. Going to hit A, and we are going to go through the steps of creating the script from scratch in our terminal. There we go. Kick that up. There we go. And we're going to do shebang, where we have the pound prompt bang symbol. And we're going to say this is going to execute in bin bash, right? So we have that at our top. We're going to type echo started, just because we're going to be nice. We're going to put in some little code things. So we're going to do echo started, like so. Then we're going to do a while loop. So we're going to do while, W-H-I-L-E, John, and we're going to do space, open bracket, space 1, space, close bracket. So we have our while loop has been created. We're going to go do that way. And then I'm going to establish the IP variable, and the IP variable is going to be this whole long string right here. Copy that. And then we're going to paste that. Oh my God, I forgot about this. I can't paste directly into this. So I get to retype it from scratch. So let's go ahead and do that. Click this. Oh, come on. The font's not that small. I got someone making fun of my font size. That's just mean to make fun of someone's font size. We shouldn't do that on that as well. All right, so we're gonna do, oh, what the hell? Oh, wait, there we go. There we go. While IP equals backtick netcat, we're going to not resolve any names. We're going to be verbose. We're going to listen. We're not going to resolve any names. We're going to be verbose. We're going to listen on port 1025. By the way, if I make a mistake as I'm typing this, guys, you guys got to do real-time proofing of my work. We're going to dump it into duplicated standard output. So we got standard error is getting duplicated standard output. Then we're going to take standard output. We're going to dump it into dev null, like so. And then we're going to pipe that through grep, and we're going to grep the string received, which I always misspell. RECEIVED. There we go. We've got that. Then we're going to pipe that through awk. We're going to do awk. By the way, fun fact, what does awk stand for? No, it's not awkward. Put in the ticks, put in our brackets, put in a space, put in the other brackets, close out the ticks. With that space, put in another tick. I'm going to put in a squiggly bracket, print. I'm going to put $3, like so. Semicolon, put in the squiggly bracket, and then I put a single tick and a back tick on that. All right, now did I type that right? Let's see if I did it. IP address, netcat, B, verbose, listen on a port, B, don't resolve any names, 1025. We have standard error is dumped into duplicated standard output. That's what the ampersand means. Then we're taking standard output, we're dumping it into dev null. We pipe that through grep, looking for the string of received. We pipe that through Oahu, Weinberger, and Kerrigan, which were the people that created this tool called awk. By the way, if you ever get into a problem where you have to solve it with awk, you now have two problems. Then we specify the delimiter is a space, which is with the two brackets, the space and then the two brackets. Single tick space, single tick, squiggly brackets, print. Let me pull this over, make sure I've got that right. There we go. Print space. We're going to print out the third value, which is the IP address. Semicolon, close out the squiggly brackets. We got a single tick and then we got a back tick. Awesome. Then what we're going to do is take that variable and we're going to put it into an IP tables. Put it into an IP tables rule. We're going to put in -a. We're going to add it to the input chain. We're going to specify the protocol is TCP, as in TCP IP, and it's not the OSI model. Not the OSI model. We're going to identify a source of the variable that we just created, which is $IP, and we're going to jump that automatically to the drop chain. Not the Dropkick Murphys, the drop chain. All right, so that's feeling pretty good. Are you guys following me? Like, if I make a mistake, I need to be typing it correct. I got to be typing it correct. So I do echo $IP has been blocked. There we go. And then we push this all the way back. Done. All right. So we've got our echo started. We do a while loop. We do the IP address equals. We've got our netcat listener setting up. We're going to grab that string that has received. So it's not going to go listening on. It's only going to print out the strings of IP on that. And then we pipe that through awk to pull out just the third value. I really should change that to cut. We've got IP tables we're adding a rule to the input chain. We're specifying the protocol is TCP IP. The source is going to be the IP address variable that we assign the netcat. We're going to jump into the drop chain. And then we echo out the IP has been blocked done. We're going to hit escape, shift : WQ, exclamation point, and then let's try to run it. So let's go ahead and make it executable. Let's go +X to our honeyport. /honey port.sh, and then let's run it. All right, started. Woo! All right. So, like I said, the hardest thing for me is hoping that copy and paste will allow me to copy and paste it out into Discord. I know awk is the bigger flex. I get that awk is the bigger flex if anybody's looking at this, but at the exact same time, I kind of want it to be useful for people. So let's go ahead and let's make a connection. We're going to go netcat to 127.0.0.1, and we're going to connect to port 1025. 1025 is the port we're going to, port 1025. We've made that connection, sending data. And when I close the connection, bam, we have our little rule fires, and it says that 127.0.0.1 has been blocked. Have you ever had a situation where you feel like you're talking to yourself too much? This is a great little script that'll stop that from happening. So if I do IP tables and I do -L, there it is. And if I scroll up, we got a bunch of rules from the Docker chains and things like that. You can see that anything that comes in from localhost is blocked. Excellent. But here's the deal. We ain't done. Not by a long shot. We have a bunch more that we can actually do. So what I'm going to do is I'm going to do IP tables -F. We're going to flush our IP tables rules, make sure that it's gone. But now we're going to do a little thought experiment here. Now that I've completely destroyed the system from ever being useful for anything with Docker ever again. So now I want you guys to think of a problem with these honeyports and things like that. The problem I talked about, and we discussed this earlier, is what happens if somebody tries to spoof an IP address, right? What would be the concern about spoofing an IP address for this, right? I think that would be a concern. I think we had somebody that maybe went through and put in the solution there. Thank you very much for that. I think that's the solution, which would be great. So let's talk about that. What would be the risk if somebody was actually spoofing an IP address for doing this? Like if I run this on one of my systems, what should I be afraid of on that? Yeah, we run into a problem where we might end up DOSing ourselves, right? We might end up DOSing ourselves. Well, here's the deal. That's not a problem. It's not a problem at all. Or more accurately, the risk associated with it is no greater than any TCP IP connection on the internet at all today. All right. Absolutely no difference on that as well. And by the way, if you're playing around with this script at home, you can log to your individual file, but you can also log within IP tables to varlog messages. If you do the -- log and -- log prefix, where it jumps to log instead of like job, you do the log, then the job, and it works. So let's do some thought experiments. All right. So what I'm going to do is I am going to run this script, and then we're going to play around with why it fires and why it doesn't fire. All right, so I start up my honeyport script, and I am going to do nmap of my local system. So we're going to go nmap, and we're going to do 127.0.0.0.1. Too many zeros there. We're going to fire it off. We sit back and we wait. There we go. Now notice, this is weird. It sees that port is open. It sees that 1025 is open on that system, but I have a honeyport there. Let's actually focus in on just that IP address. So I can do port 1025 and I can run it. It sees the port's open, port's open, port's open, port's open. Does that mean that my honeyport is broken? What do you think? Does it mean it's broken? Actually, no. It's actually working exactly as it should, because I can put in a D, which allows me to put in a decoy. And if I try to decoy, it's not going to fire. It's not going to fire. I'm decoy scanning this, and you're going to see sending SYN packets, and it's going to send SYN packets from my system, and it's going to send SYN packets from 8.8.8.8. I can put in 1.1.1.1, and I can spoof all day long, and it's not going to fire. It's not going to fire because it only fires when someone establishes a full TCP/IP handshake. So now if I try to take this and I try to make it a full TCP/IP handshake, the default nmap scan when running as root is this. We're running a SYN scan, right? We're running a SYN scan. And when I run a SYN scan, it doesn't complete. So it sends a SYN, you respond back with a SYNAC, and it fins the connection. It never completes that. So it does. No, it's not. It's SYN needs the SYN-ACK, and then it needs the ACK-ACK, where it acknowledges the SYN-ACK, and more accurately, it acknowledges the second SYN that was sent by the connecting system. If it doesn't have that, Netcat doesn't think that there's a connection. If Netcat doesn't think that there's a connection, there's no connection to log. No data was transferred. Nothing happens. And if we want to see what it looks like if a full established connection is made, watch the error message I get from Nmap as soon as I tell it to do a full TCP connection, a full established RFC 793 compliant handshake, where it completes that handshake the way it's supposed to be done. A bunch of things happen very, very quickly when I hit enter. The first thing that happens is Gordon, the author, Fyodor, sorry, the author of Nmap, says, "You're a moron. You have some options that require raw socket access. These options will not be honored for the connect scan. Specifically, what generates this error because I have decoys. None of the decoy packets are going to go because you can't spoof a fully established TCP IP connection. You just can't. I mean, technically you can, but you have 1 in 4.72 billion possible options that you have to brute force very quickly before it gets a reset. Just trust me, it's not possible. Well, it is. I mean, anything is technically possible as I'm sitting here wrestling with math. The last time that this actually worked that I know of, it was Kevin Mitnick, when Kevin Mitnick was arrested. And he hacked into a guy's name, Satomu Shimomura's computer system, and he did spoofing, but he had to DOS the system he was spoofing for it to work. So there's a little bit about it. So I did the full connect scan, and look over here, what happened? Once I did the full connect scan, then, and only then, it fired. And if I try to run this again, and I get rid of the decoys, nothing. It's filtered. What does filtered mean? Good question. If I put in a -- reason, it comes back and it says, it's filtered, John, because I received no response. I received no response. So why do I go through all of this effort to talk about this? One of the reasons why I go through all this effort to talk about this is because I want people to understand that when you're setting up something that does automatic deny listing, you're going to have haters. You're going to have haters that say, well, we can't do that because that is going to automatically, that could be used against us, right? That could be used against us and somebody could DOS our own network. That usually means that people do not understand the underlying components of how TCP IP actually works. The second reason why I'm showing you this is I'm showing you that you can totally set up cyber deception and you can run the cyber deception in such a way that, you can run the cyber deception in such a way that you don't need a tool to do it. We can do this with just the command line in a dream. All right. So there we go. Let me see if I can actually get the copy and paste for my script. We have some people that have put out their scripts, and that's awesome. Thank you very much. If we can get a round of applause for the people that shared their scripts, I would appreciate that because that's very cool of them to share. So I'm going to try to copy this right now. Copy, and let's see if copy and paste works. I've got too many things going on in too many places. Too many men, too many people making too many problems, and not enough love to go around. Nope, it's not going to work. Yep, I can copy it, but I can't paste it into Discord. But some people already did, and I will get this loaded into the GitHub repository. I know that some people were like, you know what would be neat? It'd be neat if this was in the GitHub repository. And I agree with you. So we're going to get this in the GitHub repository, and we'll make it work for everyone. So, all right. So like I said, kind of a cool little lab that ate up a whole hour of class. But once again, I really am just trying to drive home the idea that we can do this, and we can do this easily without having to set up all kinds of really, really super complicated tools, third-party tools to actually do it as well. All right, so there we go. Let me get the slides back up. do the slides. There we are. So good job. We had a handful of people that finished it. That's great. I won't do that to you again. I promise. Promise it won't happen again. All right. So let's go ahead and let's keep rolling. So we went through all of this. We talked about all of this, did all of these steps, which is great. My slides are, come on. There we go. You can do it, PowerPoint. There we go. I also have a Windows version of that one. Let me try to copy and paste this in really quick so you guys can get access to this one, because typing this one is a pain in the butt as well. So let me copy that. Let's share that in Discord so you all can play with it. There you go. So there is the Windows version out there as well. There are PowerShell versions of this for Windows. So there's a version. So there you go. I just pasted it in so you all have it. The big trick on this is where it says /F delims and it says equal, and then it has the brackets. And after that, there's 2 dashes. And I can get into why they do that, but it's just painful. But there is a PowerShell version of this as well. So you can download it and you can play with it as well. All right. So what do honeyports actually buy you? This is one of the questions that we get again and again. If you're implementing these things, what do we win if we're running honeyports? One of the things that this does is this allows us to detect certain techniques that your traditional IDS IPS systems don't detect very well at all. And most of those IDS IPS systems are blind to 0-day attacks, and we can actually detect and we can react to that very effectively. With you're looking at honeyports, you can set it up so anybody that interacts with the system at all, you can automatically assume that somebody is up to no good. If you're worried about the firewall rules triggering from a vulnerability scan, that's a really good fear, actually. With your firewall rules, you should totally set up your firewall rules where you have a rule that allows your vulnerability scanner to full access that's above the firewall rule for the block. And the reason why you want that is your rules are evaluated from the top down. So if the scanner hits it, it'll hit that allow, let the scanner do its thing, and it'll never hit the blocking rule. So you need to set that up appropriately in your environment as well. So why wouldn't you run these types of scripts absolutely everywhere? They're simple. They cause little to no impact on production at all. They're incredibly low interaction. But as I mentioned with vulnerability scanners, you may have an issue. But just make sure that you put up a rule that allows the vuln scan to get through first. It is likely, it is incredibly unlikely, that somebody may be able to use this to DOS your own environment. But as you saw, it's very, very, very hard to do. I tried doing the spoofing with Nmap. You would have to spoof that full TCP IP connection. And that's basically brute forcing a 32-bit number and doing it in less than a second. And that's, I'm not saying it's not impossible. Let's just say highly, highly, highly unlikely. And if you're worried about that, like if that's in your risk profile and that's the thing that you are just really staying up late at night, like, oh, somebody may be able to spoof that connection. That risk is no different than any of the TCP IP protocols that are out there. For every web server, every SSL, TLS connection, you have that exact same risk for everything. It's no different here as it is with those other things as well. All right, we're going to be getting into another lab, and this is PortSpoof. So we're going to take that idea, but you know what sucks about deny listing an attacker? If I deny list you, you know that I've deny listed you because the system stops responding to you, right? As soon as that system stops responding to you, as some people would point out, that's no more fun. And that automatically leads you to start changing your methodologies and your attack approach in your organization. So wouldn't it be more fun if we could keep that attacker tied in as long as we possibly could? Like just keep them hooked into the honeypot environment and they don't really know at all just what's going on. And we could generate white noise for that attacker. Well, if you ever sat around and thought about that, well, PortSpoof is the tool for you. And what this tool does is it generates random responses to every single port that the attacker tries to scan. Basically, the ports that get scanned never come back with the exact same service identification. And you're going to see how that service identification gets really weird. It can take hours to do a simple service identification scan against one system. And if we're looking at MITRE, this goes into decoy diversity. Deploy a set of decoy systems with different operating systems and software configurations to lie to the attacker. And this is what the attacker sees. Port 1 is POP3. Port 2 is a honeypot. Well done, attacker. Got me, right? Port 4 is SSH server. It's running protocol 7. Port 5 is X11. Port 6 is IMAP. Port 7 is FTP. Port 8 is unknown. Port 9, HTTP. Port 10 is SSH. We got a terminal server here on port 11, SMTP on 13, Telnet on 14, FTP on 15, 16, 17. And every time the attacker tries to rescan this, everything comes back different. As some people would say, that's just mean. I know, isn't it? Yeah. Excellent. It's delicious. And I love it. I love it whenever pen testers hit these things and then they get mad and they start crying and they're like, John, I was on a customer that went to one of your classes and they were running PortSpoof and it actually crashed my entire scanner and it took hours. I'm like, excellent. Collect your tears and send them to me. Your tears make the best wine. So that brings us to this lab that we're going to do next, which is PortSpoof. I didn't need to do that. Didn't need to do that at all. All right, let's go like this. There we go. I'm going to kill my lab environment, and I strongly encourage you to do so too, because we just totally messed with that system hard on that system. So what we're going to do now is we are going to do PortSpoof right here. And we're going to go through the steps to install and run PortSpoof. I've got standard usage, and we're going to become root. Install PortSpoof by doing apt get update, apt get install PortSpoof. May take a moment, may take a few minutes for that to show up. This is what it's going to look like. And then we're going to run IP tables again with the IP tables. But this time we're setting up the destination port is a range between 1 and 20. Redirect to port 4444, where PortSpoof is waiting for you. Then we're going to start PortSpoof. Now, you have to run your port scan from your Windows system. It has to be from a completely different computer. So you're going to open up a Windows command prompt, and then you're going to run nmap against your Linux IP address. You all remember how to get your Linux IP address, right? How do we get our Linux IP address? Anyone know? By now we should know. How do we get it? Type it in. Let's do it. All right, we need to get that Linux IP address, and then you're going to see that all ports are open. Then we're going to do a service identification scan on that system, and you're going to see that all the services come back as TCP wrapped. The reason why is it's getting a SYN-ACK coming back, but it's not able to query that service and identify what that banner is for that service. And I'll show you what the banners of services look like here in just a couple of minutes. Then you're going to feed it a services file, a signature file for services, and you're going to rerun it, and you're going to run your nmap scan 1 to 10. You're going to do service identification, but remember your Linux IP address will be different from mine, and you're going to get some results back. Your results will not be the same as mine. And then we got some cleanup steps here as well. And then I recommend destroying your VM and starting it over, which I'm going to do right now while you all are working on this lab. So this lab is going to take us through the break, and it's also going to take us another 20 minutes to do this lab. So we've got 30 minutes, 10-minute break right now, and then 20 minutes to do this lab. And what I want you guys to do is I want you to do some math. I want you to record how long it takes for it to run that scan against 10 ports, okay? And then based on that, how long would it take to run a scan against 65,536 ports that are out there as well? So, all right. So with that, let's get rolling. What? All right. So I will see you on the other side of the break, everybody. All right. There we go. So I'm just kind of jumping ahead. All right. So once again, This particular lab, the goal of it is to create a tool that creates this amazing smoke screen for attackers. And part of the challenge that I wanted you to think about was try to understand how long it would take for a like a pen tester, security assessor, or a hacker to successfully enumerate all of the open ports on a system that's running PortSpoof. Now, when we're talking about installation scenarios, generally you wouldn't install PortSpoof on every single system. Usually setting up PortSpoof on one system per subnet is more than enough to completely mess up an attacker's scanner. Why is that? Well, the reason for that is because whenever an attacker is scanning a subnet or a range, they're going to be scanning multiple IP addresses in conjunction with each other. And that's because Nmap is a multi-threaded tool. It has that capability, right? And in Nmap, you can actually adjust up and down the number of threads that it's using for scanning concurrence. So when you're scanning a network, if you have one of those systems that's like a huge sink, it'll completely seize that entire Nmap scan or Nessus scan, and it'll be caught up on that one system. So we'll talk about that a little bit more. Now, I went through the instructions where I went through and set up the APT update. I installed PortSpoof. I've got all of those things set up and ready to go. It's installing the new database. And I want to kind of cover some questions that people ask about this. Like one of the questions that comes up is it possible to have PortSpoof run on a random large set of ports rather than every port? You can chunk it within ranges. So you can do like 1 to 10, 1:10, and then like, let's say 89 to 200 or whatever. You can set it up, but it's not one of those things that's like you can just set it up on any random port and avoiding those different ports in that. But understand that that's not the point. In fact, it doesn't actually make any difference. The goal and objective whenever you're running PortSpoof is to completely destroy a scanner's ability to be able to finish in an appropriate amount of time. So an example of this would be whenever we're running a scan against an environment in a large network segment, whether it's running on something like Nessus or it's running on something like Nmap, they're really bad at telling you what it has done and what it hasn't done. Nmap will tell you percentage completion, but it doesn't kick out and say, these are the systems I've scanned so far. It kind of holds all of that until it's complete, and then it flushes it out to a file. Now, there is a trick to get around this. If you believe your scanner is stuck, all you have to do is disable your adapter, and it'll automatically cause the scan to finish and flush what it has up until that point. Let's talk about psychology and what is it? The sunk cost fallacy. A lot of people, when they're gambling, they think I have lost a lot of money at gambling. Therefore, I need to gamble more because my luck is going to change. Or if somebody, there's a great Tom Hanks movie called The Money Pit in the 80s, where you keep sinking money into a house and your thought process is, I've already sunk money into this house. How am I going to get out of it? Well, I'll just keep sinking more money into it. That same fallacy is in the heads of attackers and pen testers that are out there, where they're getting a scan, the scan is doing its thing, that's all fine, that's all dandy. However, they aren't getting a feedback that's accurate of where that scan is hung up. So if they kill that scan completely, they do not know if they have to start from scratch and redo all of that work again, or it's caught on like the last 9%. So let's go ahead and play around with PortSpoof, and let's give it a shot. So I've already gone through the instructions and have it installed on my system. So I'm going to get my IP address by running ifconfig. My IP address for my Linux system is 10.10.237. Oh, you know what we should do? What we really should do at this point? Let's go ahead and let's change our settings and let's set up our appearance to make it bigger. All right, we're going to set it up towards bold. Java is updating. Not today, Satan. We're not going to do that. We're going to set it to be bold, crisp, cool, and refreshing, like the mountains of Montana. Montana. All right, there we go. I have my IP address present and accounted for here. 10.10.237.14. Let me pull this up. And then we are going to run PortSpoof. Now, when PortSpoof runs, it's just there's no parameters, so it's switching into an open port mode, which is basically exactly as it says on the can. It's basically going to say that every one of these ports are open. So let's go ahead and let's do let's do an Nmap scan. And I'm just going to restrict my scan. We're going to do, oh, I completely skipped a step. Hold on. Yeah. Let's do this. Let's reset that. There we go. I completely skipped a step, a really important step. That step is the firewall rules to reroute the traffic from ports 1 to 20 and redirecting it to port 4444. That is the default port that PortSpoof listens on. So anything that comes into ports 1 to 20 is going to be rerouted and directed to port 4444, where PortSpoof is going to basically lie to them and all the connections that are made. So now we've got it up and running, but I still need that Linux IP address as well. We go ifconfig, and let's run our nmap scan. So we go nmap, and we're going to run it against 10. Let's get our ports. Let's go nmap, and let's do P. We're going to go 1 through 10, and then we're going to run it against 10.10.237.14. Once again, your IP address will be different on that as well. So we give it a second. It says that all 10 of those ports are open. Now notice that was really fast. Like it completed that entire scan. What did it say? It took like 3.13 seconds. That's because it was simply sending a SYN packet, got a SYNAC, closed that connection, 10 ports, really, really small subset of ports. And it's trying to guess what the service is. So it says TCP MUX, CompressNet, unknown, RJE, Echo, discard, all of those. It actually doesn't know that that's what those ports are. It's guessing based on what those ports normally have running on it. If I want to get the real deal, the straight dope, if you were, I could do an SV scan. That's where it's going to interrogate that service to try to identify in more detail what that service is. It's going to take a little bit longer for this scan to run, but it's going to come back with a response that everything is TCP wrapped. And that basically means there was no response. The port was open, but there was no response. So what we want to do is really mess with port scanners like Nmap. And to do that, we're going to feed in a services fingerprints file on the system to lie more thoroughly to Nmap. So we're going to put in a signature file like that. We run it, and now we rerun our nmap command. Now we went from 3 seconds to 10 seconds, and now let's see how long it takes to rerun that scan to do service identification on this particular system. So, all right, waiting. So one of the questions that may come up is, how was this services identification file created? There's a couple of different ways. One of the ways that you can do this is Nmap has a services file that it uses to fingerprint services. So PortSpoof actually reflects that same fingerprint back to that particular file, which is pretty cool out there. That's another way. We're working on a new tool. I think it's called GoSpoof. That's written in Golang. I might share that with you, but it's a new BHIS project, and it's a little bit different. All right, so my system just finished its scan. Let's take a look at what it said. So it says that it scanned these 10 ports in 36 seconds. 36 seconds. Let's play a game. While I'm walking through the services file and what we have, you tell me if it scans 10 ports in 36 seconds, how long will it take to scan all 65,536 ports that exist on a computer system? So let's put in some math in there and show your work, by the way. A long time is a good answer that we get. So right now you can see that it's still identifying these services, and some of them it's very clean, right? It's very, very, very clean. It says this is postfix SMTPD, Cisco Wireless Control System for FTP, First Class Messaging System Control, Telnet D, LP scheduled, and then we have a Teletronics phaser, printer webmin port, but then we get to some ports that it was not able to identify. You see, it was unknown for the port 8. It was unknown for port 4, 3, and 2. For those particular services, this is the basic data that PortSpoof sent Nmap that looks like absolute gibberish coming back to it, right? So literally it was just sending back, this is Kerberos over SSL, SIP, this is a voice over IP device. If we're looking at this fingerprint for this particular system. What's this next one? Port 3. It's got a Larga web server right here. So it's basically feeding that web server data into it. The next one, oh my gosh, I don't even know what this one is. We got a PC Windows. I don't think it's a Windows service at all. But that's a completely different service. So Nmap wasn't able to identify what these services were, so it dumped out what those service fingerprints are. So it took 36 seconds. So how long is it going to take to scan all of the different ports that are out there, right? So if we're looking at that version scan for 10 ports, I saw someone say 64 hours. I haven't done the math associated with it, but I do know it's over a day, right? So it's going to take an entire day to scan 65,536 ports. And this gets into why it's so critical for you to think of this in terms of not just those 10 ports, but looking at it in terms of this. So instead of doing the 1 through 10, I can now put it in 1 to 65,536. And this is how your scan looks. Oh, I got to do 35. I forget there are 65,536 ports, but 65,536 is not a port. There's 65,536 ports because 0 is a port. There we go. Now it runs. All right, so if we look at some basic math on this, it's going to be 65 hours roughly, right? So that's a really long time. And the actual math will vary. And also understand this is the best case scenario. These are two systems sitting on the exact same subnet, the exact same subnet. Now, if I'm an attacker and I'm running this, this is all Nmap gives me. It's not flushing out the results as it's seeing it. It's just hung, right? So I don't know as a pen tester if it's stuck. I don't know if it's a honeypot. I don't know if it's just finding a bunch of services on this network. It's just giving me this really, really basic information about the connections. And that's why this works so well. Because we go back to detection time plus reaction time must be less than the amount of time it takes for an attacker to successfully try to break into an environment. So if we're looking at this, we have now greatly increased the attack time, and the attacker, we're in their OODA loop, we've blinded them. So their ability to observe has decreased. Their time required to attack has gone up through the roof. It's gone crazy. Now, some people may ask, could you customize PortSpoof responses with some Canary tokens? You possibly could. And like I said, I'll be sharing you a GitHub repository to an updated version of PortSpoof, let's say after the next lab and the next break on that as well. So that is the PortSpoof lab. I am going to destroy and recreate my virtual machines, probably because I have a weird God complex, you know? It's like John giveth the VM, John taketh away the VM. So don't forget to destroy and restart your VMs on this as well. So, and by the way, the timing of this is going to take a lot longer. It's going to take a lot longer when you're actually scanning over the internet. It will not be anywhere near as fast as it is on this particular environment where they're right next to each other on that as well. So with PortSpoof in the enterprise, I recommend setting it up. So like honeyports, you can use a variety of different honeyports, right? We can use honeyports and setting up port spoofing like PortSpoof. We can use honeyports and we can set that up emulating real services. We're going to talk about artillery here in a couple of seconds as well. So let's talk about Kipo and Cowrie. Another new lab that I've updated, getting people familiar with Docker. We have had students in this class over the past few years that have been like, you know, what about Docker? Can we use Docker? I think The name of the tool is called GoSpoof, and I'll talk more about that as well. Maybe I can bring in the authors of GoSpoof. They can talk about it as well. So Keepo and Cowrie is different than PortSpoof. It's different than just a simple port that's listening that blocks you. This is a tool that's emulating a full SSH service on a system. So what we're going to do in this lab is we're going to fire up Cowrie and Docker, and I'm going to explain to you how like Docker has these really long directory paths and overlay to, and what that actually means, and how you can edit your Docker container and the files contained therein. We're going to go through a lot of that on how we modify Keepo or Cowrie for it to look different when somebody's connecting to it as well, because we want to grab that SSH login information, but we also want to see what the attacker is doing after they log in. Because if we do it right, we get this. We get a situation where we can see the commands the attacker ran. And these are a number of commands an attackers ran in the past, right? They tried to change the permissions on nohup, kill all, rm, wget. They made a directory called plugins. They killed the existing backdoor, downloaded a new version of the backdoor from that IP address, and then they tried to restart the backdoor. This is great. This is so cool because it gives you the ability to now do threat intelligence, which brings me to my threat intel rant. A lot of threat intelligence, I think, is garbage. If you're looking for compromised accounts, if you're looking for info stealer logs, I think that threat intelligence is awesome. If you're looking for tools, techniques, and procedures that an attacker does, I think threat intelligence is awesome. If, however, you're looking for evil IP addresses or domains, I think threat intelligence is garbage. It all depends on your use case. This particular situation is one of the customers we had at Black Hills Information Security, where we got these commands off of a live honeypot that was coming against our customer at that time. And we now know that there's an IP address, 119.1.109.43. And I know if anybody is trying to talk to that system and has an outbound connection, it's probably popped. I now have a port 4443. Anybody communicating on that port, probably popped. Now I also have the name of the executable in an environment. I can do a query across my environment and see if anybody is running a tool called Linux Time. I know that they're popped. I know where those files exist. This isn't threat intelligence against somebody else's organization someplace else down the line. This is threat intelligence against your environment real time. This is powerful threat intelligence. So you should be looking at how to run Cowrie in the enterprise. We'll talk about this more after the lab. And this lab is going to take us a little bit more time. It's going to take us until 30 after. Because we're going to modify, we're going to do some change settings on the Cowrie instance. So it takes a little bit longer. So if you were my moderator and you were going to reset the clock, we'd want it to, there you go. That looks much better. Awesome. Very good. So we're going to run Cowrie. You're going to open up a Kali prompt. You're then going to become root with sudo su space minus, and then we're going to run Docker. You can run this on any system that has Docker installed. This command will work on any one of those systems. So you're going to run the Docker container. Then you're going to open up another Kali prompt. You're going to remove the SSH known host. You're going to want to do this every time. One of the ways that Cowrie was detected for a long time is the SSH key fingerprint changed constantly, or sorry, it didn't change. It was static, so you could detect it. Now when it runs, every time it runs, it does a new SSH key fingerprint. Because it's on the same IP address, your system freaks out. So we're just deleting our known hosts from our key fingerprints. Then we're going to connect to it. And then we're going to try a password of 12345, and you're in. You're now logged in successfully. But you're going to notice that if you run commands, ID, who am I, password A, you're going to see those logs show up. But you're also going to notice that the service has the name server04. That is consistent for every single Cowrie instance. So what we're going to do is we're going to kill the session by hitting Control C at the same time in your log session. Then you're going to edit this really stupid long path. Now, the reason why there's a stupid long path is Docker creates a unique directory for every single Docker container because they really don't want namespace collisions for Docker containers. So they come up with this randomly long string, And we're going to do overlay 2, which that is the user editable layer for a Docker container. And we're going to edit this file right here, Cowrie CFG DST, right? So we're going to edit that file, and then we're going to scroll down to line 30. You're going to see the host name is server 04. You're going to change that server name to something else. Then you're going to escape, WQ, and then your return key. Then you're going to restart your Cowrie instance. Then you're going to remove the SSH known hosts again, reconnect, log in, and you're going to see your prompt change. Next, we're going to change the message of the day. You can change it to whatever you want it to be. It's under message of the day. You can edit it. I put in something stupid from the Hitchhiker's Guide to the Galaxy. And then I'm going to escape, WQ, return, restart, reconnect, and then you're going to see your banner has changed on that as well. And then there's a great resource on modifying the individual files in Cowrie and all the different things that you can do. So this lab is going to take us up to through the break and to the bottom of the next hour. So about 38 minutes and 42 seconds. So with that, let's get to the lab. Let's do a break, and then I'll do the walkthrough. Let's get rolling. Let's go ahead and let's get a couple Kali prompts up here. Doing Kali things. All right. So a quick question. What was the name of Kali before it was Kali? Anyone know? Kind of doing a little bit of, that was Backtrack. What was Backtrack called before it was Backtrack? Linux is a good answer if you're choosing Linux. It was Knoppix STD, Security Testing Distribution. Knoppix STD had a picture of Felix the cat in the background. It was an awesome distribution. Yeah, Knoppix STD. So. All right. So let's go ahead and let's get started with this lab. I got both my terminals up and running, and we're going to play along with Cowrie for a few moments. So the first thing I've got to do, because I'm starting up a Docker container, which involves virtualization and opening up network ports, is of course, got to become root. Got to become root if I'm going to be doing all that stuff. As soon as you start messing with ports and listeners and IP table rules, got to be root. And then we're going to start Cowrie, which is super easy to do. We're just going to go ahead and start up Cowrie. Now, the first time that you run Cowrie on a computer system that you've ever ran, it's going to download a whole bunch of like basically broken up components and parts of that particular distribution. Cowrie has already been ran on this system. So when we have that overlay 2 and all those different types of directories that are out there, we run into a situation where it's going to pull all of those down for a remote brand new system that you've never ran it. And when it runs it locally, excuse me, it's trying to start up from scratch a whole virtualization environment out there. So here we got Cowrie. Took a few seconds for it to run. Took a few seconds, but after it got done running, it's now ready to receive. We are now ready to receive, programmed to receive, if you will, connections coming in. So in my other terminal, I'm going to remove my known SSH hosts. We're just going to blow that away. And you'll notice that I do that every single time that I'm going through and I'm trying to set up a new connection. And that's because the SSH key fingerprint changes every single time you restart Cowrie. All right, so now I'm going to open up a connection as root. We're going to type yes for the key fingerprint, and we're going to put in the password of 1, 2, 3, 4, 5. Why didn't anybody tell me that that was the same code as their luggage? And I am in. Now, whenever I'm in this distribution, I can run commands like ID, I can do who am I can do a whole bunch of A's, just tons and tons and tons of A's. So many A's, you guys. And you'll be able to see all of the commands that I ran over here, right? So we're seeing these SSH connections coming in. And once someone comes in, we can then see the command was id. We had the command was who am I? And we had the command of, and it couldn't find the command. So that's great. However, if we're looking at this particular honeypot, there's some dead giveaways that we're dealing with the Cowrie honeypot. The first dead giveaway that we're dealing with, or we used to deal with, was the SSH key fingerprint. And I'll show you what that looks like here in just 2 shakes of a lamb's tail. But the other reason why we have a dead giveaway of this particular honeypot is you can see the server name is server04. That is the default prompt for every single Cowrie distribution you ever see. And then you also have this, we have this like warning banner right here that is going to be the same for every single Cowrie distribution that is on the planet. So I'm going to exit out of Cowrie and I'm going to click in here, Control C. We're going to kill our Cowrie instance. The reason why we're killing the Cowrie instance is because we're going to change the configuration. All right, we're going to change that configuration so it looks a little bit different. And we're going to edit this super long file. Now, this is just what Docker does, and it makes some sense on it, but this random string of characters that it generates for the directory name is a way for you to uniquely identify and separate out your Docker instances. And they use this really long string to make sure that there will never, ever, ever in the history of the entire universe, up until the heat death of the universe, have a collision of Cowrie directories. And specifically, we're going after the overlay 2 directory because that is the directory that is editable by us as a user. So we're going to go ahead and we're going to copy that one. We're going to paste that in there and we're going to edit this file. So it gives us a few seconds for Vim to start. And I'm going to go to the 30th line, roughly, and we are going to change the host name. I'm going to go ahead and hit A to allow me to edit, like it says in the instructions. And I'm going to put in Landshark, like that. All right, Landshark. There we go. Yes, that is a Saturday Night Live reference. If you go down here, there's a whole bunch of really cool configs that you have. If you try to download a file, where is it going to download it? Where is the data? What are the libraries, state path, the Etsy directory? And it has excellent descriptions of what these things are. Like, where is the Honey file system? How do we deal with editors? What are the text-based commands? So if you try to go through and modify Cowrie, it's going to give you a bunch of options on how to modify Cowrie. The other thing that's really, really, really cool is if you get down at the bottom, it gives you different logging options. So you can log into, have Cowrie log directly into different SIMs and log analysis tools that are out there as well. So it really is a good idea to go through and just play with what these different options are for you to connect into these different services that you have out there. And some of these configs are for SSH. Some of these configs are for Telnet as well. So I'm going to escape, shift, I'm going to hit my :WQ, exclamation point. We're going to kill it. It's dead. All right. So now I have to restart my Kali instance, and I want to show you something. All right. So I'm going to start up Cowrie again. This is going to take a second. There we go. And now we're going to reconnect to the Cowrie system, right? Reconnect to SSH. Now look what happened. Look what happened. I didn't delete my known fingerprints file. And the reason why, and this is actually really, really, really critical, is it says it's possible that someone's doing something nasty. They could be eavesdropping. Here is the key fingerprint for this remote host. The key fingerprint for this system rotates and changes every single time you restart it. And that's actually a good thing because, like I said, some earlier versions of Cowrie, the way that vulnerability scanning tools would detect that it was a honeypot is they would look at the key fingerprint and see if it was a default Cowrie key fingerprint. And if it was, they would not allow you to connect, they would not scan that system. So if I delete that file, I reconnect, it's going to re-import that key fingerprint, 2, 3, 4, 5, bam. Now my terminal has changed. And just like that, my terminal now says Landshark, right? Once again, that's very common for people that are writing tools to identify honeypots, and for people that are going through and like attackers, as soon as they see that server 4, they know to get out, get out, get out. It's bad, it's bad, it's bad. All right, so that is one configuration, but I want to change the configuration of the logon banner as well, because that logon banner is the exact same login banner for every single Kali instance on the place of the on the planet. So what I need to do is I need to edit my message of the day, MOTD. So I'm going to edit that file with that really long path that we have there. And I'm going to change this because I don't like any of this. And we're going to edit it and go away. Right? We're just going to change it to something terse, straight to the point. This is not a honeypot. There we go. So I'm going to close out, right quit, close it, and now we're ready to restart again. So we're going to start up that that Cowrie instance. And now we're going to delete that SSH known host file. And now we're going to connect. I'm going to put in the password like that. And now my banner has changed. So this is like a little bit of what you can do to configure and modify Cowrie. And I think it's just phenomenal. It's a great tool. You are going to have to do a little bit of modifications and things to it. You can integrate it with your existing logging infrastructure, which is equally cool on that as well. But this is just the beginning of a number of different honeypots that give you that ability to emulate an actual service on that as well. So if we're looking at this, we can see if an attacker is putting in a simple backdoor. Are they trying to download and upload files? Are they just doing DDoS booters? Do they have a valid user ID and possible passwords? Many organizations have users. You can actually add in users. There's a user database. And in that link that I gave you at the end of the lab, you can see how you can add and remove different users. And you can see if somebody's trying to log in as a root user. You can see if somebody is trying to log in as a user that is a named user on that environment as well. So we can see if that site is compromised and see if people are trying to attack legitimate accounts. This is called a credential stuffing attack. So if I have a bunch of valid user accounts like Bryce, Strand, S, Mick, Mike, Ethan, Lawrence, Paul, Larry, and I have valid domain accounts, I now know that I'm dealing with a targeted attack coming against our environment. I am not dealing with some like weird script kiddie that is trying to go after root and Tor and admin, whatever default creds that they run into. We're now looking at this where we are seeing them come after direct connections on that as well. Now, one of the questions I get a lot is it saving the passwords that people try? Absolutely. It is constantly saving the passwords that people try coming into the environment, which is cool. So we did that Cowrie lab, which is awesome. Now let's talk a little bit about some other tools. We don't go through every single tool that's out there, but there are other tools that emulate services. This is an excellent tool from an excellent company by the name of TrustedSec. It would have been really, really just an awesome, cool tool if it was just a honeypot tool, but it also has some file monitoring, which I think is pretty cool. If you set up a file like the Etsy shadow file where your password hashes exist, and somebody goes in and they try to modify that Etsy shadow file, it'll automatically generate an alert that someone is doing something that they shouldn't be doing on that particular computer system. One downside of this tool is it emulates the exact same services if you run it directly out of the box. You can modify the default ports so it doesn't show up the exact same ports again and again and again and again over and over. You can say, well, on this network, let's have it be RPC SMB. On this one, let's have it do VNC, and so on. You can modify it pretty easily. There's also more evil web servers that are out there. Tons of just All kinds of options. And one of those options is a tool called Web Labyrinth, created by a gentleman by the name of Ben Jackson. He took that spider trap idea and he really took it up a few notches. And he came up with an instance that you can implement inside of a PHP implementation in your environment. One of the things it does, it tells Googlebot to go away, has some other really nice touches. One of my favorites is the random wheel of errors. So imagine that you have a great big 100-sided dice that you play Dungeons and Dragons with, a great big, huge dice that you play Dungeons and Dragons with. Now, anytime anyone connects, if they land on 16, it gives you 404 not found. If it lands on 23, it says 403 forbidden. If it hits 42, it says 402 payment required. Why is it doing this? Because if you work with a standard spider trap instance, and that spider trap instance is constantly sending the same responses again and again and again, there are automated crawlers out there that'll learn that that is probably a honeypot trap. And you have to put in a little bit of spice, a little bit of excitement into what it's giving back to that scanner so that it doesn't think it's being caught in a trap, right? We want it to keep going as long as we possibly can. You can also take any text file of your choosing, and instead of it showing a random like directory from the big list from Durbuster, you can feed it entire books. The default that it comes with is Alice in Wonderland, where it takes random words and it basically sets those words up as the honeypot there as well. Now you could go through and you can make it so you're reflecting back at the attacker because they're usually using an automatic crawler. You can make it so every single response has an indicator of a cross-site scripting and SQL injection attack. This is for one of those situations where you just don't trust your SOC analyst to not respond or to respond properly to a single alert. Like, hey guys, there's an alert over here on our honeypot. You should probably look into it. I mean, maybe if you want to, you might want to do that. No, we want it to set off a Roman candle. And what you would do instead of a standard Alice in Wonderland config, you can actually reflect snort rules directly at the attacker. So your intrusion detection system will now freak out because it's literally seeing intrusion detection systems alerts flipped right through it. So it's like we said, Roman candle, lots and lots and lots of stuff going on. Now, that idea of SSH, that idea of something like Web Labyrinth is getting us into application-specific honeypots. And there's a number of application-specific honeypots that are out there. Think SCADA ICS systems, right? We want to blend in and we want to create something that an attacker thinks is a SCADA system. And if they try to interact with it, we can make them work and realize after a while that they're not dealing with an actual SCADA system. So here's one of the honeypots that was out there a number of years ago called Conpot. And Conpot emulates Siemens PLCs. And the problem with it is it gives you the exact same values again and again and again, which once again makes it very detectable. And there was some research that was done by Darren a decade ago, where he said these are the key values that you need to change for this honeypot to not be recognized as a honeypot. Because if they set this up, the attacker then continues to run, SCADA attacks against it. And once again, it gives you a better opportunity to detect what's going on. So we're going to do a really simple web honeypot, really, really basic web honeypot. And this is going to be the last lab of the day that we're going to work with. And I'm going to go ahead and I don't know, I think I need to, but I'm going to do it anyway because I like it. I'm going to destroy my lab and I'm going to restart it. And then we're going to go into the web lab web honeypot right there. And this is going to emulate an on-prem exchange system, which no one should be running on-prem exchange. Just so you know, whenever an attacker sees on-prem exchange, they get all Twitter-pated, super excited. They're like, hey, this is it. One shot, one kill. We're going to get in. And you still see a lot of on-prem exchange servers. So this is going to mimic an Outlook web access portal. And we're going to show you what it looks like when someone runs a full web vulnerability scan against it when you stand it up. And this lab will take us until 15 minutes after the next hour. So we're gonna have a break plus 5 minutes on the other side. So you have almost a half an hour for this particular lab. So let's go ahead and let's start the timer on that. I'm gonna start my lab, so it's gonna be piping hot and super fresh. It will take a while for Z attack proxy to start in this particular lab, but it will kick up and it will work just fine. Just give it a little bit of time. All right, so with that, let's get rolling. We'll resume at 15 after, everybody. All right. Last lab of the day. We got the last lab of the day. All right. If you're taking this class in days, this is the last lab of the day. All right. Some of you may not be doing it that way. That's okay too. All right. So I started up a fresh, brand new virtual machine. It's got that fresh virtual machine smell, which for some reason smells like hot transistors and stale body odor. Or maybe that's just the IT team that we deal with here. I'm not sure how that actually works. All right, so we are going to do a couple of things. One of the things I'm going to do is I'm actually going to start up Z attack proxy at the beginning because it takes a while for Z attack proxy to start up. And then we're going to start up our Kali instance, and we are going to start up the damn small vulnerable web app tool. I'm just going to open up a Kali here. There we go. Going to go ahead and accept that. And then I'm going to go ahead and make this terminal. And change the appearance. We're going to change the font. Go ahead and choose bold. I can't think of anything funny to say about bold. I will tell you, I am a little bit curious. They don't have any fun fonts. What would be the most disgusting, horrible font to choose? Yeah, we'll just leave it like that. I'm going to have to add in some really good fonts in there. Like Comic Sans. It'd be great if it had Comic Sans. It doesn't have Comic Sans. I think every terminal should be a Comic Sans terminal there. All right, so we have our Kali system running. Z attack proxy is in the process of starting up. There it goes. And let's get started. So we're going to CD into opt OWA honeypot. CD into the opt OWA honeypot. And then we're going to start it up. Now, this is awesome. This particular honeypot is, without question, the smallest vulnerable web server in the history of like all vulnerable web servers. It is really, really super small. It's crazy. So I'm going to go ahead and start. I don't want to persist the session. I'm going to get another little pop-up about updates here in just a couple of minutes. I'm just going to close it. I don't care. Because I don't care. I like it. Then we're going to choose automated scan. And one of the things I didn't get from my Kali system, because I'm a moron and I'm not following my own instructions, is the IP address of my Kali Linux system. So I'm going to go ahead and grab that IP address for ETH0, which is 10.10.210.213. We're going to put that in there. And then I got to do in colon, and I can't remember exactly what the port is, but the really nice thing about it is whenever I start up the damn small vulnerable web app, it tells me what is the port that is, the OWA honeypot. I'm getting that one confused. Sorry. So we've got our, the Exchange web server. It's not, I'm getting my labs mixed up, and I am sorry. It's not the damn small vulnerable web app. That's a completely different web app lab that we have. This is the OWA honeypot lab. I'm crossing classes. Guys, I gotta be honest, I've been teaching nonstop for like 5 weeks right now. So it's a little bit crazy. But let's go ahead and look at what that web honeypot looks like here. Apologize profusely, my bad. We're gonna paste, and we're just gonna go. We're just gonna YOLO connect. So we've got the domain username, and I can put in my domain name is there we go. And then I'm going to put in my password is something leet. There we go. And then I'm going to try to sign in. Now on the back side, you'll see that we're starting to get like connection attempts coming in, and you can see those requests coming in. And some of them, the Python server is like, I don't know. I don't know what's going on here. It's just crazy and it's weird like that. But let's actually show you what an actual attack looks like. So we're going to go ahead and kick off the attack here. It's going to crawl the website. I'm going to go through and spider it. We're just going to go ahead and go OK like that. And now it's going to start the actual attack active scan. If we go back to our OA web honeypot over here, so much attack, so much like just so many bad things going on here. I used to reference Drake. It'd be like a lot of bad things we'd be wishing, but referencing anything with Drake is not a good thing these days because Kendrick destroyed Drake. I think that everyone agrees on that. It's pretty bad. No one thought that they would be talking about the Kendrick Lamar and Drake beef, but they not like us. All right, so this is what web attacks look like. And the reason why I like this is because we do web app security assessments. And it's very, very common for people to say, well, there's nothing we could have done. Like BHIS did this attack against our web server, and there's no way we would have known it. It's impossible for anyone to have seen what Black Hills Information Security did to our website. And I like to point out to them, it's like, oh no, there's a lot going on here. Yep, we could have done nothing. Not a thing. I'm like, no, there's literally thousands of logs that were generated by us attacking your website. Yep, nothing we could have done at all. Yeah, that's not the reality of the situation, right? When you're looking at somebody launching a web app scanner, and attackers do this all the time, right? They use automated scanners just like legit pen testers do. It's very, very common for us to see this. There's thousands and thousands of records of the attack. And that sets up two separate things. One, whenever we're talking about legal liability, if people are like, yeah, there's nothing we could have done to stop that web app attack, all I need to do if I'm doing expert witness stuff is I ask for their web logs. And as soon as I get the web logs, it's like, yeah, we have 422,000 entries from the attacker's IP address and you missed it. It's not going to go well for them. The other thing about that is knowing that that's true, the amount of noise that is generated on that is the fact that if they're hitting a honeypot once again, there's going to be a lot of alerts that are generated from that. It's going to be a lot of alerts. And if you have your web attack honeypot that's tied into the rest of your security architecture, I'm going to be able to slow that attacker down, right? I'm going to be able to see that attacker, you can see the source IP address is 10.10.244.86. And stream of garbage coming from that IP address. And you can totally start setting up a deny list approach for that. I could talk about it now because they've never been a customer of ours. Not that I'm bitter, but Apple computers. I had a friend of mine, this would have been about 6-7 years ago, that was on the security team for Apple. And he was talking about how they set this up. And after a certain clipping threshold for honeyports and web honeypots and all of those, they just deny list the IP addresses that are launching these attacks coming into their environments. And one of the things that he shared with me that I thought was a very interesting perspective that I never had thought of before was the fact that he said by deny listing these IP addresses that we know are running attacks against us, we save hundreds of thousands of dollars per year. I was like, what? He said, think of this. If we allow these scanners, if we allow the attackers to continue to attack our websites, if we don't shun and deny list them, that generates thousands and thousands of logs in our logging facilities. And in our logging facilities, we're putting that up in the cloud. Even back then, they were getting started with some of their cloud technologies. And we have to pay for that storage and we have to pay for those transfer fees. So if we can cut that attacker off at the pass, right? We want to cut them off immediately for them trying to do that attack. We're going to save money in the long run. That's a really, really, really good approach, right? The other thing about that is the signal to noise ratio. If we can clean out the script kiddies if we can clean out the skidiots, as I like to call them, and those people that are the ankle biters and they're scanning and they're doing really stupid attacks, it's going to clean up the signal to noise ratio, and it's going to help you develop better, appropriate response strategies for the more advanced attackers that know how to do things in a low and slow type of fashion. And that's the goal of this lab. So we've done an SSH honeypot, we did some honeyports today, and we did an actual honeypot emulating an OO web server on that as well. All right, so let's go ahead and let's take our pivot now. Time to take a seat, and we are going to move into the Ask Me Anything. So I'm going to close out my virtual machine. We're going to go over and we're going to support Discord. We're sharing Discord. Destroy. There we go. Destroyed my VMs. You should destroy your VMs too. That would be a really good idea on that as well. So what questions do you have for me? We didn't get as far in the class as I wanted to, and I had a really, really cool story I was going to tell you about law enforcement and the kidnapping case. And that's going to come up tomorrow. We're a little bit behind, but that's okay. I usually end early. But when we're looking at tomorrow, I'm going to share that story. We'll talk about how we can track really, really, really bad people, like kidnappers and things
Hey,
like
John, there's a question in Zoom.
Oh, sure.
It says, you recommended using the Windows firewall during the Nmap lab. Is it best practice to run before each lab or only when told?
I don't understand the question too much. I would only run the firewall when told.
Okay.
But don't ever turn on your firewall. So when it pops up and it asks, do you want to turn on, just click yes. Sorry, do you trust this network? You click yes on that as well. Syntax, which I love the name, by the way. How do you approach things like Cowrie, honeypots, and a purely cloud deployment in an environment on that? It's the same way that you would run it locally, right? But your implementation is going to be a little bit different. That's why we kind of cover the Cowrie lab as a Docker container, because in cloud environments, you can actually spin up Docker containers and things of that nature as well. What else? When customizing Cowrie configuration file, are there any default settings that can be commented out? Also, renaming the host name, would it be smart to give it an organizational name? I like the organizational name approach, but most of the stuff in the config I leave as is. I don't comment out many things in that situation out there as well. For somebody with career cybersecurity advice, basic networks, I lost the whole, I can't, let me try to pull up where's my Discord? There's my Discord. There it is. Let me go to that question. For somebody, there it is, in career cybersecurity, assuming basic networking, OS, and programming are covered, should I focus on one area of red or blue team focus or both at the same time? I would focus on both of them at the same time. And I would also recommend that you go look at the video series of your 5-year plan. That would be a really good point because it kind of addresses that in a whole hour on that as well. Russian FSB agent got the source code, yeah, from HP. I don't know. The SIM space is really weird right now. What's a good limit threshold attempts before blocking IP address? I'd be comfortable with like 10, 15, maybe even 20. A lot of people, they like to see 3 or 5. And the problem I have with like 3 or 5 is it's way too tight. Way too tight to kind of do some of those things as well. I just recommend giving yourself a little bit of breathing room on that as well. Do you recommend having a team or part of a team dedicated to standing up and maintaining deception? No, it should not be a dedicated team. If you're spending a whole bunch of time, effort, and money standing up and running your deception, you're doing it wrong. Most of your deception should be the set it and forget it, Ron Popeil style cyber deception. Low interaction, high fidelity, where if anyone's interacting with it, we know beyond a shadow of a reason of a doubt in the back of their children's minds that we're dealing with some type of attack or somebody that's doing something that they shouldn't be doing in that environment. So good question. And there's the 5-year plan for getting started in security. So check that out. It's funny, Master of Disguise is like everybody has memes of that movie. No one ever can make it through. That one and The Love Guru is another one. I wish I could hand this out to more. I handed out some of these over the weekend. Some people in my area. Get us offline your address and we'll ship you a crate of them. How does that sound? It may take a while if you're overseas, but we'll try to ship you a whole bunch. Because the whole idea is to make that stuff as accessible as possible in Recca. All right. Any other questions? This could be a short day. Gimme comics. Nice. I want to party with that guy. Hypothetical. If I worked for NSA and knew the top officials of a foreign adversary use Signal group chat to communicate, how would you try to gain access to those groups, i.e. to fake a contract with an official phone number? That one's easy. So the way that you would do that is you wouldn't try to crack Signal directly. What you would do is you would try to gain access to one of their phones. And if you're looking at like NSO Group and other adversaries, in particular the NSO Group, they have capabilities to do a 0-click, 0-day to gain access to those particular devices. And in those situations, once you gain access to like the equivalent of root, it's relatively easy to gain access to those types of things on that as well. And if you don't know, NSO Group has been out there for a while. Pegasus softwares that got people all worked up. I didn't care about Pegasus software. I genuinely cared about how they were actually getting access to those things. Pegasus and the malware itself is not that interesting. The initial access operations that they have is really, really top notch. Do you endorse, endorse purple teaming? Absolutely. And one of the things I like to say is there is no red, there is no blue. We're all purple, right? Like red team's goal should be improving blue. Blue team's goal is working with red to improve blue. So we're all purple all the time. Have I encountered any significant cybersecurity incidents or cyber attacks recently? I have, but I have an incident response team. I have a SOC team, and I have very strong non-disclosure agreements. So won't get too much into that. I will tell you, it's a lot of ransomware. Like, I could give you, we got some pretty cool incidents that we've worked with. There was one of the BHIS employees got popped as an admin level staff, not a tester, not management, no one working with contracts, but support staff. And they got popped by the attacker had compromised a group that we were talking with actively that was looking to hire us to do a pen test. And that group got compromised. The adversary saw that that group was talking to BHIS about a pen test, and they sent us a link. And they said, hey, we signed the contract. This came from our customer's email. We were able to trace it back, working with the customer. The hacker took over a customer's email and sent us an email with a malicious link. That was scary. Right. And we're working on some things to try to elevate security at BHIS, but our contract team is dealing with those things all the time, right? We're dealing with people sending us contracts, sending us links to different portals. So it's a really, really super advanced attack out there. My team is trained, right? Like they're very, very well trained. And the person that clicked the link even looked at the email headers, made sure that it traced back to the organization, confirmed it was the same email as the organization, and then went to the customer's portal to download the signed contract. That is crazy on that. If you're working on a small team, Active Directory and Office 365, go get Ping Castle and go get Graph Runner and run both of those to get some level of security for those types of things on that as well. All right. What else do we have? Any questions? How do I access the exam and CTFs for the certification? We can share my screen back. Let me share my screen. And we'll share that one. I want to share the whole screen. Yeah, let's do that. Share the whole screen. All right. So I can't remember where you go to from here. I think you go to Meta CTF as the logo. right here. Once you're in here, you have the cyber range that you can access. But if you scroll down, you also have the certifications. We also shared a document in resources that Zach created that had step-by-step instructions, I thought, as well. Did they? I know that we had that. Megan, can we get that from Zach? I don't know if it made it into the
I thought
resources.
I
I saw it.
posted it. I'll
I
find
think
it.
it got posted to the main. I don't think it got posted to resources.
Dang it. Well, I'll do
Yeah, it's
that.
okay. We'll get it in there. We got you. Got you. All righty. What else do we got? Can you talk about the InfoSec hands-on training tool that you're doing across the US? We're starting in DC, and one of the things I love teaching virtually, it's great. And one of the reasons why I quit the SANS Institute was because I was spending more and more time away from my family. I was spending about 1 week a month away from my family, and SANS was getting really pushy whenever I wanted to pull that back. So I resigned. It got to the point where I was losing money every time I was teaching for the SANS Institute because I wasn't pushing BHIS. And it was fine. It was all amicable. And things were good. But now all my kids are grown and out of the house. I'm an empty nester, right? And my wife and I, we really like to get out there and see people. And I know that there's a bunch of people out there that really love to meet us. And the BHIS team loves to get out and meet people. So we are absolutely going to hit the road. So check that out. D ask, what class should I take next? We're starting Intro to SOC Core Skills in a couple of weeks. So I'd recommend checking out that class. If you haven't done that, you should do that on as well. Yeah, we are absolutely looking for additional universities, folks. If you have a university, especially in the summertime, that we can gain access to a couple of auditoriums. We're not looking for small classrooms because we're using large numbers games. So if you have good sized classrooms that we can seat 100 to 200 people, that would be awesome. Guatemalaco, if you could just, Megan will get a hold of you. Megan, can you get a hold of them on that as well? But yeah, we're trying to find universities around the United States and populated areas and getting people out there. So please, we will work on that together. For a team that's focusing on purple team engagements, what are the things you would recommend focusing on? I would recommend focusing on I would start with like the basics. I would work with that ping castle. I would work on the like graph runner, try to lock down those things. And then my intro to security class, like the 10 things that we cover there are really the triage that you should be focusing on in an organization on that as well. So look at what we cover in the intro to security class on that. How many people have passed the ACE-T certification? I have no idea. I should know this. We have that on the back end, and Roman, the guy at MetaCTF, has that data. I know it's more than 2 because we had a couple of people that have gone through and they let us know on that as well. What does one do in the cyber range? They're just like CTF. Yeah, they are. They're just like CTF challenges, and they're basically set up at different levels. So they have points, and the lower the points, the easier the skill is. And then you can kind of work your way up over time on that as well. So you're changing the world for the better because you got bored. What the hell else am I supposed to do? Like, I love mountain biking. I love rock climbing. I can do mountain biking in DC. I can do rock climbing almost anywhere in the United States that has a climbing gym. And those things are cheap. You know, it's like gasoline. These are things that are cheap for me on that. So just, yeah. Is the SOC course skill on demand? It is, but it's also on YouTube. If you go to the Anti-Siphon website and you go under live videos, it has the archive of live videos, and we have a whole bunch of the archives for those classes available out there as well. Miss Maltov, shoot an email to consulting at bhis.co. If you want to talk to us about pen testing, consulting at bhis.co.
I think they were asking about training. I told them to reach out to support.
Yep, reach out to support. Oh, yeah, sorry. I thought it was BHIS, not the training. My bad. Yeah, so Intro to SOC Core Skills is out on YouTube for free. Did I speak about my CIS training? Yep, we are. We are now the official CIS training provider from the Center for Internet Security. And somebody can get a link out there if Nynema, somebody can get a link for our official CIS training class. I would appreciate that. Can BHIS adopt me? No, but here you're always family. There we go. It's okay if I give an in-depth article about this course on Medium? Absolutely. Um, Absolutely. And you should put in your course. We've had a couple of rough labs. This is the first time we've moved it to this platform. And I apologize profusely. We're cleaning up the labs. I know we've had a couple little small hiccups, but you always have something whenever you go live in production. But overall, it's been pretty slick. I've been pretty happy with it. There's my CIS class. So check that out as well. Where can I get this shirt? You can't. This one's special. This is a limited edition run. But if you want to get next year's, you got to enroll in the Cyber Collegiate Pen Testing Competition. What's the latest or one of the most recent things that excited me in InfoSec? So training is always something that's near and dear to my heart. Okay, so here's a weird answer to that question. We have a number of testers that have worked engagements in Russia and China, right? Which is rare. You don't see that a lot in the industry, right? And we got the opportunity to start looking at technology stacks for Russian corporations and Chinese corporations or US corporations that have offices in China. And one of the things that's absolutely eye-opening is just how different their technological stacks are for Russia and for China, and how insecure those things are. So we've been doing a lot of research into various technological products that you can acquire, doing product level security and vulnerability research. And that's been really super exciting to me. And what we are seeing is for something brand new. And in a lot of ways, they're way more insecure, a lot more insecure than US companies are. And I want to explain why. If you look at the United States, we're getting hacked constantly, right? China and Russia are attacking us directly with no fear whatsoever of attribution. On the news last week, there was someone like, yeah, if you see an attack coming from Russia, you could pretty much guarantee it's not Russia. And I was like, well, tell me you know nothing about nation state level activity without saying you know nothing about nation state level activity. Russia and China, they just attacked directly. Now, for a brief period of time in the Obama administration, Barack Obama went over and talked to China and was basically like, stop. And they did. Not really. They just started pivoting through third parties and organized crime groups instead. But they did slow down for a little bit. But up until that point, it was just like open season. And if we're looking at right now the way that things are going, you got the teleco infrastructure is compromised, things like that. And we are now seeing these adversaries just attacking like with no interest at all on protecting themselves. They just know that we're not going to do much about it. And they know that the Chinese and the Russians aren't going to, they're not going to do anything about it, and they're not going to get caught. So it's just, they're going to do that all the time. So really, 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 if you're looking at it, the United States has more antibodies built up than a lot of these countries. And that's one of the things that doesn't make any sense to me, right? Like if you're Russia and you're China and you're constantly picking on us, right? And I'm going to talk about the F-35 here in just a second. And you're constantly picking on the United States, you're just making us stronger, right? You're constantly attacking organizations. We're developing better and better antibodies, becoming more and more resilient in a way that we aren't seeing in Russia and we aren't seeing in China. And I don't know, man. I just, if things got into a total cyber war, I know that there's people in the United States that are like, well, China would win. No, they wouldn't. They have really good access into a number of different things, but they're in a glass house throwing stones. They may have more access than we have at this particular point, but trust me, they are wide open to a number of attacks. And that's one of the things I wish the United States would invest more in. And this isn't giving away anything classified. Most of the people that are training for, are training in like offensive skills in the United States, They're actually trained how to hack US organizations, right? As far as I know, Anti-Siphon has the only class. Oh, there's one more. But there's two classes that we know of that are targeted to hacking foreign infrastructures, right? One is by Anti-Siphon, it's Steve Baroche, and I can't remember the other dude. That's it. Most of the classes that you learn in like the US Navy Red Team or the Army Red Team and all of these different things, you're learning how to hack Active Directory. You're learning how to hack cloud services at Google and Microsoft. And that's a bit concerning, right? We need to get better at that as well. So the F-35 jets. So it's interesting. The Chinese stole the plans for the F-35 jets a long, long, long time ago. But in that meantime, the United States did a test flight where one of the test pilots flew over the international date line, and there was a computer glitch in the code that caused the entire F-35 to shut down. Now, thankfully, in that particular scenario, he was able to restart the jet and save himself. That's great. Good for him. Well done. Cue the theme from Top Gun. However, the Chinese stole a lot of stuff associated with the F-35, and that bug still existed. And they had a number of planes that crossed the international date line that were ripped off in the F-35. And rumor has it that a number of them went down in the ocean. And that's tragic. I don't like loss of life under any circumstances. But yeah, that's kind of an example of like China is really good at stealing stuff, but actually doing maintenance operations and keeping these things going is really difficult. It's kind of like Afghanistan. When we left Afghanistan, that was kind of a nightmare, and I don't want to get too much into politics of it, but there was a bunch of people that were like, oh, we're handing over all these weapons and stuff to, the Taliban. That's not true. The amount of effort it takes to maintain a tank or a helicopter is ridiculous. And if you're talking about what the United States is really good at, better than any other like force in the world, it's ops, right? Like keeping these systems and these weapon systems running and functional at a long distance on that as well. Was it intentional? No, originally the time change shutdown was not intentional. That was a mistake in code. Yeah, logistics, ops, operations, logistics. Yeah, like that. Steve Baroche's class, I can't remember what the name of it is. It's on Anti-Siphon on that as well. Do you know of any good cybersecurity meetups in the DC area? Do me a favor, Jay Frost. Do a search for DC. Has nothing to do with DC. It stands for DEF CON. Do a search for DC in your area code, and there's a bunch of DEF CON groups in that area based on your area code. So what technology stack exists in foreign nations? Anything we can compare it to? Look at just Google, what is China using for cloud services? And then you have a Staro Linux in Russia, and then you have a bunch of like Active Directory replacements, email replacements that you can see on there as well. Oh. Cat videos. All right. All right. So with that, let's go ahead and let's kill it today. Tomorrow's the last day. Like I said, I've got that story I'll tell you tomorrow. Now, I want to ask DMPT's question. Oddly unrelated, I worked for the government. Do aliens exist? Okay. You can't go away. We're going to hit the alien thing. I will echo what Barack Obama said officially on David Letterman a long time ago. There's weird stuff out there we can't explain. So how's that? However, another way to put it is I want you to take a quarter and I want you to set it on the counter. Okay. I want you to take a single quarter and put it on the counter. And I've got this little thing right here. I've got a single thing about the size of a quarter. And I want you to imagine that quarter is the size of our solar system. Okay. It is the size of our solar system. All right. And if that quarter was the size of our solar system, the United States is roughly the size of our galaxy. All right? So if that quarter is the size of our solar system, the galaxy is the size of the United States. And if that quarter was the size of our galaxy, the known observable universe is 6 cubic miles, like cubed. And this gets into the thing from this gets into right here, the Hitchhiker's Guide to the Galaxy. Space is big, really big. You wouldn't believe just how vastly, mind-bogglingly huge it is, right? And if you think about that, I can't remember the guy that talks all the time about space. You know, that can kind of freak you out a little bit. There's a lot of space in space. And I don't know, I just find that really cool that no matter how bad I can screw up in my life, I can't screw up that bad, right? Because the universe is a very big place. And now, whether or not aliens find us interesting or not, that's a whole nother story. And with that, let's get out of here. Thank you very much, everybody. We're out of here.